Before addressing the announcement, it's essential to comprehend what particle accelerators are. The Large Hadron Collider, LHC, operated by CERN, is a 17-kilometer loop of superconducting magnets and stands as the largest and most powerful particle accelerator on the planet. It represents the apex of human scientific achievement. In fact, its strength is such that it can recreate the very conditions that existed during the birth of the universe. But could this machine, designed to unveil the universe's secrets, also hold the potential for something much more alarming? CERN, established in 1954, is one of the most esteemed scientific institutions globally, encompassing 23 member nations and thousands of researchers. It serves as a center for collaboration and breakthrough innovations. The LHC is CERN's most significant undertaking, but it is only one component of an expansive network of accelerators and scientific trials. Picture a racetrack, not for automobiles or horses, but for subatomic particles engaged in a race against both time and space. The LHC propels protons to almost the speed of light, sending them on a collision course that mirrors the universe's energy at the time of the Big Bang. These collisions generate temperatures that are millions of times hotter than the sun's core. Thousands of magnets steer the protons on their path, while sophisticated cooling systems ensure the magnets stay colder than outer space itself. The beams inside the LHC are designed to crash at 4 specific points around the accelerator ring, which align with 4 particle detectors: Atlas, CMS, ALICE, and LHCb. Each detector serves a distinct purpose in exploring different facets of particle physics. Together, they function like enormous cameras capturing images of these collisions. The collected data is meticulously analyzed for any signs of the elusive Higgs boson, commonly known as the God particle, and other phenomena that could provide clues about the universe's fundamental building blocks. By investigating the microscopic world, we gain a better understanding of the larger cosmos. However, with every answer discovered, new questions arise, and each breakthrough brings fresh challenges. The LHC is more than just a scientific tool. It is a monument to human curiosity and ingenuity. It symbolizes our relentless quest for knowledge and our drive to comprehend the fundamental forces shaping our existence. Yet, as we push the limits of our understanding, we must also reflect on the ethical and existential questions that accompany this exploration. What dangers lie in probing the unknown? Could our pursuit of knowledge accidentally unlock forces beyond our control? Within the hallowed halls of CERN, where the edges of human comprehension are constantly tested, a revelation has emerged that sends chills even through the most experienced scientists. Brian Cox, a former CERN researcher and prominent figure in particle physics, recently made an announcement that has captured both the fascination and fear of the global community. Cox's statements resonate with a chilling clarity. The aim of CERN's LHC is to recreate a miniature Big Bang. Yes, you read that correctly. An incredibly small version of the very event that birthed our universe. The physicist also elaborated on the implications of this ambition, emphasizing the LHC's exceptional potential for making groundbreaking discoveries, including unlocking the mysteries of the Higgs boson and investigating dark matter, a mysterious substance that constitutes a substantial part of the universe. Imagine possessing the power of creation, the ability to summon the very essence of existence. It's an enticing prospect, but one laden with peril. The miniature Big Bang is not just a hypothetical idea. It is a very real phenomenon within the LHC. The temperatures, pressures, and raw energy generated within the LHC simulate the conditions of the universe's infancy. It's akin to standing at the dawn of time, witnessing the birth of everything we know. However, with such power comes immense responsibility, and the question remains, what if something goes wrong? In fact, something did go terribly awry in 1978. Russian physicist Anat Borsky faced an event that would profoundly change his life. While working with the U-70 synchrotron at the Institute for High-Energy Physics in Russia, a malfunction caused his head to enter the direct path of a proton beam. The beam, with a force beyond comprehension, passed through his skull, entering the back of his head and exiting through his nose. Borsky's experience was nothing short of surreal. He saw a flash brighter than 1,000 suns but felt no pain. The beam's trajectory caused localized destruction, burning through tissue and bone, yet he remained conscious and even walked to the clinic for treatment. The aftermath was both shocking and remarkable. The path of the beam caused tissue death, resulting in hearing loss in one ear and partial facial paralysis. Astonishingly, Borsky's mental faculties remained intact, and he continued his scientific career. This incident is not merely a personal tragedy. It serves as a stark reminder of the immense power and inherent risks of particle accelerators. The dangers associated with an accelerator like the LHC are not to be underestimated. The potential for unforeseen reactions and the manipulation of space and time itself are not merely the stuff of science fiction. They are real concerns expressed by some scientists. One of the most disconcerting possibilities surrounding the LHC's experiments is the chance of generating a miniature black hole. Black holes are regions of spacetime where gravity is so intense that even light cannot escape. They are cosmic vacuum cleaners, devourers of stars and mysterious entities lurking in the darkness of the universe. The prospect that the LHC could create such an entity, even on a tiny scale, is both terrifying and awe-inspiring to the public and experts alike. Could this black hole expand uncontrollably, consuming Earth from the inside out? While scientists at CERN assure the public that any black hole created would be unstable and would evaporate almost immediately, the mere possibility has sparked debates, fears, and a sense of wonder about the power we wield. To understand how the LHC could create a black hole, we must first grasp the fundamental mechanics of particle accelerators. When protons collide at nearly light speed, the released energy is so vast that it distorts the fabric of spacetime. Picture a taut trampoline with a heavy object dropped onto it. The fabric bends and warps, and if the object is massive enough, it can create a deep depression that draws everything nearby into it. This is a simplistic metaphor for what could occur inside the LHC. In the quantum realm, where the universe's rules become both strange and beautiful, there is a theory that extra dimensions may exist beyond the ones we can perceive. If these extra dimensions are real, the LHC's collisions could access them, generating a gravitational funnel that forms a microscopic black hole. This mysterious interaction of particles has even captured the attention of world-renowned scientists, such as the late Stephen Hawking. In his writings, Hawking cautioned about a scenario in which the Higgs boson could become unstable at exceedingly high energy levels. This instability could lead to catastrophic vacuum decay, a cosmic event that would not only obliterate Earth but potentially destroy the entire universe. The esteemed British cosmologist and astrophysicist Sir Martin Rees also voiced his concerns regarding experiments at CERN. In his book on humanity's future, he examined the potential risks associated with particle accelerator experiments, including those conducted at CERN. His warnings were not merely theoretical. They conveyed a sense of existential anxiety. He described a worst-case scenario where an experiment gone wrong could lead to vacuum instability, potentially triggering a phase transition that would ripple through spacetime, resulting in a cosmic catastrophe capable of consuming the entire universe. Rees further calculated the probability of such a disaster, acknowledging that the likelihood was low, but even a slight chance should prompt caution. The stakes are astronomically high, and the margin for error is razor-thin. CERN scientists have conducted thorough simulations, calculated probabilities, and analyzed these theories to demonstrate the safety of the LHC. In fact, Brian Cox himself has emphasized the significance of responsible scientific exploration. He acknowledged the widespread concerns about the LHC's operations and reassured the public that strict safety protocols are in place, with extensive reviews to ensure the accelerator's activities are carried out with utmost care. Cox emphasized that the energy levels involved are far within the Earth's natural capabilities, and the likelihood of creating a stable black hole is virtually non-existent. Even if one were created, scientists believe it would be so small and unstable that it would evaporate almost instantly, a phenomenon predicted by Hawking known as Hawking radiation, a brief flash of energy, and then it would be gone. Some have gone further, speculating that the LHC's experiments could open a portal to another universe or dimension. Though largely dismissed by the scientific community, this idea has captivated the public's imagination, sparking fear, fascination, and even contributing to various myths. What could lie beyond our reality? Could we unknowingly unleash forces or beings we do not comprehend? The concept of opening a portal to another realm has even been sensationalized in the media, further fueling uncertainty. But how did this notion arise, and what does it mean in the context of scientific inquiry? The concept of parallel dimensions is not new in physics. String theory, a leading candidate for a unified theory of everything, proposes that more dimensions exist beyond the familiar three of space and one of time. These additional dimensions could be compactified or hidden from view, but in theory, they could be revealed or accessed under extreme conditions. Now, envision the LHC as a key to unlocking doors that have remained sealed since time's inception. When protons collide at energies never before reached on Earth, They could, in theory, tear through the fabric of spacetime, potentially exposing these hidden dimensions. While the scientific community remains skeptical about such extraordinary claims, the idea that particle accelerators could hold the key to understanding the universe has captured the attention of many, prompting both excitement and fear about the potential risks and consequences of these experiments. Ultimately, the LHC symbolizes humanity's insatiable curiosity and ambition, standing as a testament to our progress in understanding the universe. However, it also serves as a stark reminder of the dangers that accompany this knowledge. The universe may be vast, but as we continue to uncover its mysteries, we realize just how little we truly know. The quest for knowledge is one of humanity's greatest achievements, but it is not without uncertainty and peril. Time will tell whether we are prepared for the discoveries that lie ahead. The LHC is a triumph of modern science and technology, but it also raises questions that challenge the very foundation of our understanding of the cosmos. As an engineering marvel stretching over a vast underground ring, it features some of the most advanced equipment ever created. It brings together scientists and researchers from all corners of the world, united by the common goal of answering some of the universe's most profound questions. But as scientists push the frontiers of human knowledge, they also face significant challenges, both theoretical and ethical. One of the central objectives of the LHC is to explore the forces that govern the universe. For centuries, scientists have sought to understand gravity, electromagnetism, and the strong and weak nuclear forces. The LHC provides an unparalleled opportunity to study these forces under extreme conditions. The high-energy collisions of particles simulate the environment present just moments after the Big Bang, when the universe was a hot, dense soup of particles. This allows researchers to study the behavior of matter and energy in ways previously thought impossible. Yet, despite the immense potential for groundbreaking discoveries, the LHC also raises important questions about the limits of scientific experimentation. The discovery of new particles, such as supersymmetric particles or dark matter, could radically change our understanding of the universe. However, these discoveries could also introduce unintended consequences. There is growing awareness among certain physicists that the experiments conducted at the LHC may not just reveal the secrets of the universe but may also uncover new dangers or forces humanity is unprepared to confront. One of the most intriguing and unsettling concepts is that of vacuum decay. This theory suggests that the energy produced by particle collisions at the LHC could cause a catastrophic shift in the fabric of spacetime, initiating a chain reaction that could alter the very nature of reality itself. While the likelihood of such an event is minuscule, the potential consequences are so dire that some argue this risk should be carefully considered. A vacuum decay event, if it were to occur, could result in the collapse of the universe as we know it, potentially leading to the destruction of all matter and energy within our cosmos. As scientists continue to explore the boundaries of particle physics at CERN, the risks associated with these groundbreaking experiments cannot be entirely dismissed. The potential consequences of unforeseen phenomena like vacuum decay, or the creation of an uncontrollable black hole, continue to fuel public concerns. Despite reassurances from the scientific community, the implications of pushing the limits of our knowledge and technology are profound. Even as we unlock the secrets of the universe, we must remain vigilant, aware of the unintended dangers that could emerge from our pursuit of understanding. The quest to understand dark matter, dark energy, and the fundamental forces that govern the cosmos continues to drive research at CERN. These forces, gravity, electromagnetism, and the nuclear forces, are the key to unraveling the mysteries of the universe. The LHC offers an unprecedented opportunity to study them at the smallest scales, simulating the conditions that existed just moments after the Big Bang. However, as these experiments delve deeper into the fabric of reality, they also raise fundamental questions about the limits of scientific inquiry. The LHC's primary mission is to uncover the particles and forces that govern the universe. The discovery of the Higgs boson, for example, confirmed the existence of the so-called God particle, a crucial piece in the puzzle of how matter gains mass. But with each new discovery, scientists confront the possibility that the very nature of the universe is far more complex and far more dangerous than we have previously imagined. As particle accelerators like the LHC push the boundaries of science, they also bring us closer to the edge of understanding forces we may not yet be equipped to control. As we probe deeper into the quantum world, there are concerns that we might inadvertently trigger events that could destabilize the universe itself. The concept of vacuum decay, for example, suggests that the energy released by particle collisions could destabilize spacetime, triggering a catastrophic chain reaction. While the chances of this happening are exceedingly low, the potential consequences are so catastrophic that the possibility cannot be ignored. If such an event were to occur, it could result in the destruction of all matter and energy in the universe. While some argue that the risks of such events are remote, others contend that the stakes are simply too high to ignore. The LHC represents humanity's greatest hope for unlocking the mysteries of the universe, but it also symbolizes the tremendous responsibility that comes with pushing the boundaries of knowledge. We may uncover answers that have eluded us for centuries, but we must also recognize the potential dangers lurking beneath the surface of our scientific pursuits. There is also the ethical dimension of scientific experimentation at such extremes. Should we, as a society, be willing to risk the future of humanity and the universe in the pursuit of knowledge? These are not hypothetical concerns. They are real questions that must be addressed as we move forward in our exploration of the cosmos. As we strive to understand the universe, we must ensure that our actions do not jeopardize our very existence. The future of particle physics, and the role of the LHC, will be shaped by our ability to balance curiosity and caution. While the potential for discovery is immense, it is crucial that scientists continue to prioritize safety and responsibility. The LHC has already yielded incredible breakthroughs, such as the discovery of the Higgs boson and advancements in our understanding of particle physics. But with each new discovery, we must ask ourselves, what are the unintended consequences of these revelations, and how can we mitigate the risks? As the LHC continues to push the limits of what is possible, the potential for groundbreaking discoveries is matched only by the potential for unforeseen consequences. The future of particle physics lies not only in the discoveries we make, but also in how we navigate the complex ethical, philosophical, and existential questions that arise from our experiments. The pursuit of knowledge is one of humanity's greatest achievements, but it is not without its risks. As we continue to explore the deepest mysteries of the universe, we must remain aware of the potential dangers that may accompany our discoveries. Ultimately, the LHC represents both the promise and the peril of human ambition. It is a tool for understanding the universe at its most fundamental level, but it also challenges us to confront the unknown with humility and responsibility. As we continue to unravel the mysteries of the cosmos, we must ask ourselves whether we are truly prepared for the consequences of our discoveries. The quest for knowledge is not only about understanding the universe, it is also about understanding ourselves and our place within it. The LHC may provide the answers we seek, but it is up to us to ensure that the pursuit of those answers does not come at a cost we are unwilling to pay. In the end, the LHC and its experiments represent a dual-edged sword. On one hand, they offer the promise of unlocking the most profound secrets of the universe, potentially altering our understanding of reality itself. On the other hand, they expose us to risks that are impossible to fully predict. As scientists and society at large, we must continue to engage with these questions, balancing our thirst for knowledge with the recognition of the immense responsibility that comes with wielding such power. In the years ahead, the experiments at CERN will undoubtedly continue to push the boundaries of what we know about the universe. As the LHC operates at the cutting edge of particle physics, new discoveries will unfold, and new questions will emerge. But with each new breakthrough, we must remain vigilant, asking not only what we can learn, but also what we should learn, and what the potential consequences may be. The future of particle physics lies not just in understanding the universe, but in ensuring that our pursuit of knowledge is undertaken with wisdom, caution, and a deep sense of responsibility.